Calculate the potential energy between negative 100 microcoulomb and a negative 200 microcoulomb charge separated by 30 centimeter. We have part B and part C. Let's read it later on. So first of all, I need to find out the potential energy between. Potential energy can be calculated using this formula. K times Q1 times Q2 divided by R. So that will be 8.99, which is Coulomb's constant, times negative 100 times 10 to the power of negative 6 times negative 200 times 10 to the power of negative 6 divided by R, which is 30 centimeter. I need to convert it to meters, so it's going to be 0.3. So that will be 599.33 joule. Part B. It says, what is the potential energy between 100 microcoulomb charge and a negative 500 charge separated by distance of 5 millimeters? So that will be K, Q1, Q2, R, 8.99 times 10 to the power of 9 times 100 times 10 to the power of negative 6 times negative 500 times 10 to the power of negative 6 divided by 0.005, because I needed to convert 5 millimeter to meters. So that will be 8.99 times 10 to the power of 9 times 100 times 10 to the power of negative 6 times 500 times 10 to the power of negative 6 divided by 0.005. That's going to give me 89,900. It is much bigger because here, first of all, Q2 is bigger. Second of all, this one is a lot smaller. Since it's in the denominator, it's going to make it bigger. Part C, it says how much work is required to bring two identical 100 microcoulomb charges to a distance of 1 centimeter that were initially very far away. So when we have two very far charges, the potential energy, or let's say potential energy like E of E equals to 0. Why? Because K, Q1, Q2 over R, when R goes to infinity, the whole ratio is going to go toward 0. So whenever R goes to infinity, potential energy is going to go to 0. Now in the second condition, we need to have them like 1 centimeter away from each other. So E of E final is going to be K, Q1, Q2 divided by R, 8.99 times 10 to the power of 9. Q1 is 100 times 10 to the power of negative 6 is identical, so I'm going to make it squared, divided by R, which is the distance between these two particles, which is going to be 0.01 centimeter. You convert it to meters. 8.99 times 10 to the power of 9 times going to be 8.99. It's going to be 8.99 times 10 to the power of 3, or I can say 8990 joule. So it's changing from 0 to 8990. So amount of work you need to apply is going to be minus delta E of E, which is going to be final 8990 minus 0, which is going to be negative 8990 joule.